second lesson of the week. We are still in Pythagoras. We're doing the converse of Pythagoras. I'll explain what that means. Page 185, exercise 2. Okay, what was Pythagoras? Pythagoras was that in a right angle triangle, a squared plus b squared will be equal to c squared. Okay, the sum of the squares of the sides is equal to the square of the hypotenuse. Converse tells you that if you've got a triangle, and you don't know that it's a right angle triangle, let's say ABC, and you know if BC squared plus AB squared is equal to AC squared, the sum of the squares of both sides equal to the square of the other side, the third side, then angle B is 90 degrees. Okay? So it works the opposite. If the sum of the squares is equal to the square of the third side, boom, right angle triangle. Okay? So please copy that, make a note of that in your book. Okay, you can pause me and do that, and then we'll do our first example. So, I'm giving 3 sides, lengths of different sides. Okay, I should have kept that triangle. Okay, so we'll say this is A, B, C. Okay, we tell me that one side, AB is 24, BC is 7, AC is 25. Now, this is an aside. How did I know to write 25 as this side? Because, well, this is the biggest side. So you can see I drew it. I thought about before that. Okay, AC is the biggest side. Therefore, I left 25 for it, if that makes sense. Okay, now I'm given these lengths, and I want to prove that it's a right angle triangle. How would I do that? Okay, so what was Pythagoras' converse theorem? It told us that if the squares, the sum of the squares of both sides equal the square of the third side, boom, it's a right angle triangle. But how do I know which one are the sides that I need to add? Maybe I need to add those 2 squares together to get that. Or maybe I need to add those 2 squares, or maybe I need to add those 2 squares. How do you know which one is the hypotenuse, the third side? Well, the hypotenuse, or the third side, by definition, is the biggest one. So which one is the biggest one? It's 25. So what I'm going to do, I'm going to do the square of 25, which I remember from our last lesson is 625. Okay? And then I'm going to add the square of those 2. Okay, 24 squared plus 7 squared. Okay, we've done that before. If I'm not mistaken, that was 576. Okay, I don't know it. I just remember from our last lesson. Okay, 576 plus 49, and that is indeed 625. And you can see I got the same number. So the square of AC is equal to the sum of the square of AB and BC. And then in the test, I'd like you to write this sign. That means therefore, okay, angle B is 90 degrees. It's not just any angle, it's angle B. We all right with that? Okay, so that's the simple kind of example that you could do. Okay, let's do another example. Please copy that into your books, just like in any lesson, and let's move to the next example. Okay. So I've got A, B, C. Okay, I'm doing example 2, by the way. Exercise 2, question 2. A, B, C, D, and I'll put in the numbers. This is C1, C2. This is 12, 15, 9, 13. Okay. All right. So with me. Okay. So I'm giving all these numbers, and I want to show that angle ABC is right angle at C1. Okay. The triangle ABC is right angle at C1. What does it mean, C1? Okay, this is the angle C1. In other words, I want to show that C1 is 90. I want to show that. They don't tell me it's 90. I need to prove that it's 90. Well, how do I do that? Just what we've done now. Okay, we've got this triangle. Okay, I don't want to copy that. I just want to read in the question. We are in question B. It's not question 2, it's question B in exercise 2. So I want to prove that C1 is 90. So I've got these three sides, and I need to show that the sum of the squares of two sides will be equal to the square of the third side. Which one is going to be the third side? The 9, 12, or 15? Which one is the hypotenuse? It's going to be the big one. So it's going to be 15. So I'm going to do 15 squared. Haven't got a clue how much it is. Anyone knows with that calculator? I'll be impressed. 225. Okay, right, 225. And now I need to show that 9 squared plus 12 squared, hopefully it will be 225. 9 squared is 81 plus 12 squared. Do you know anyone? Should know. 144. Okay? Yeah. And that is actually equal to 225. Yeah, it is. Okay? So therefore, C1 equal 90 degrees. Okay? Okay. Right, so that was B part 1 of that question. In 2, if you look at 2, I'm reading it. Why is C2 equal 90? This is C1. I know it's C1 90. Why C2 is 90? Okay? So I'm just going to erase that. Make sure you copied it before so you know how to answer the rest. Okay? Right? Now, here we got to remember things that we learned last year from Euclidean. Okay? If C1 is 90, I know that C1 plus C2, remember these little hats that shows that it's an angle, they have to be equal to, correct, 180 degrees. And remember what reason we gave that? Okay? Adjacent angles on a line. Sum of adjacent angles on the line. They add up to 180. Okay, so if C1 is 90 plus C2 is 180, C2 is going to also be 90 degrees. Okay, pretty easy, eh? Moving on to the third part. That was the second part. The third part, I don't know if you'll be able to see it. Yeah, I think you'll see it. Yeah. Okay, the third part. Now I'm asked to calculate line CD. How would you do that? Well, now I know this is 90 degrees triangle as well. It's the second triangle. Okay? This is 12. This is 13. So now I can do what I did in the first lesson. I'll use Pythagoras theorem. Not the converse Pythagoras, but the Pythagoras theorem. Okay? So I'm going to write down, okay, 12 squared, that's one side, plus the other side square, CD squared, equal 13 squared. Okay? 12 squared is 144, plus CD squared, equal 13 squared, I think it's 169. Okay? Can you still see it? You can still see it. Now, if I want to find out CD squared, I've got to get rid of the 144, right? So I'm going to do minus 144. If you don't mind, I'm going to write that down here. See a bit better. So CD squared is 169 minus 144. That's 25. Okay? It's 144. Sorry, it's 25. And therefore, CD is equal to 5. And we've got the answer. Okay. That's it for today. Cheerio.